Good morning. So we were discussing about operators in MATLAB. So we are in OPS, operators. So we have been discussing about various operators such as plus, minus, product, left division, right division, then braces, different kind of braces, then dot. So all these things we have been discussing. Today we shall discuss some other operators such as a percentage, exclamation, assignment. We have discussed all about this assignment earlier. So then continuation, 3 dots for continuation. Then you please look at the computer screen now. So in the computer screen we can see the several operators which you have already opened it by using doc OPS. So they are all called punctuations. If you go to MATLAB and write help punct, you will find all these things will come up. What are the different punctuations you can see? Decimal point, array operations, field access, then parent directory, CD, continuation, comma, semicolon. So I can just tell you about few of them. For example, let me tell about what is called this continuation, 3 dots. So what is this 3 dots? This is one form of punctuation. Suppose I am writing in A is equal to B. That is a statement itself. Suppose A is equal to 3 and B is equal to 8. So I shall write C is equal to A plus D. A plus B, let us say. So this is a complete statement by itself. So it will give you result. But suppose I write C is equal to D is equal to A plus B plus, then it is not a complete expression. So it will give you errors. So what I shall do is I want to continue this statement in the next line. Then I can write C in the next line, I will get the result. Therefore, 3 dots implies a continuation. Clear? Then I shall tell you what is transpose. Suppose I have a matrix X. Let me say I have a matrix X, which is, I will just equate it to some random matrix. Let us say 3 by 3 random matrix. Right? I have another matrix, let us say 3 by 3 random matrix. So if I want to make X transpose, if I write Z is equal to X transpose, then it is just X dash, that gives you X transpose. But suppose I have a matrix W is equal to X plus J into Y. What does it X plus JY signify? That means W is a complex matrix whose real part is X and the imaginary part of its element is Y. So therefore this becomes a complex matrix. Suppose I write that U is equal to W transpose. You see, this is a 3 by 3 matrix. Let me write what is U is equal to W transpose. You will find this is called Hermitian transpose. That means the W matrix will be transposed, but at the same time the elements will be the complex conjugate. For example, you look at the 1 1 element, we can write here W 1 1. We can write the elements side by side by using square brackets U 1 1. You see, you will find one is the complex conjugate but the other. Similarly, you can write W21, you will find that the other one is U21 is the complex conjugate of the other. Then in that case, how to take the transpose without making the complex conjugate? So this is done by W. Suppose you want to transpose W dot transpose. If you make W dot transpose, so there will be transpose operation, but there will be no conjugation. So you can see W 1 2, and if you see V 2 1, they will be same, is it not? So W 1 2 is equal to V 2 1. Earlier, what was the problem? U 2 1 was the transpose of W 2 1, as you can see, but here V 2 1 is not the transpose. So that is a beautiful thing. So one is dot transpose and transpose. Transpose makes A Hermitian transpose, that means the elements of the transpose matrix are the complex conjugate of the original matrix. Rows and the columns are interchanged, but if you write dot transpose, it is the simple transpose. So this does not make a difference for real matrices, because real matrices the complex part is 0. Then what is percentage? Percentage, as you can see here, is the comment. That means if you write, suppose I write a line, I'll write a mem file, suppose. So if you write something, let us I write program to simulate, suppose RLC circuit. This is not a statement, so I want to make a comment, so I will put a percentage here. You can also comment it by pressing Control and R. Control and R will comment it, and Control and T will uncomment it. Sometimes you need to comment certain statement and then uncomment it quickly, so you use the keyboard Control R and Control T for commenting and uncommenting. This is easy, right? So this is called percentages for comment. So let me close this one, not required, so I will not save it. So it is, I will close it. So then dot dot, as you know, it is just the parent directory. That means in the whatever you did in ordinary operating system, cd dot dot means it will go back to the previous directory. Semicolon will be used for, there are two things to use the semicolon. As you can see here, if yourself semicolon punctuation, there are two uses of semicolon. That is, one is used to start a next row, and semicolon is also used to suppress the echo. For example, suppose I write z is equal to w plus u. If I put semicolon, it will not be echoed. Similarly, I can also write semicolon. Let us say I want to write a matrix D which is equal to 1, 2. Then if I put 3, 4, that means the semicolon automatically tells you that the next elements will be in the next row. So you can see 1, 2 semicolon means it will go to the next row. So this is the use of semicolon, either to suppress the comments and also to go to the next row. So these are some of the very important punctuations. Then you have an exclamation. What is exclamation? So exclamation will just have a cell escape. It is called cell escape. If I write exclamation dir, it will operate on the operating system directly. The operating system commands can be executed here. See, I am writing exclamation dir. This is the operating system command which is telling you about the directory structure, etc., etc. Right? Similarly, I can write exclamation notepad. You will find the operating system directly opens you the notepad. Suppose I will write exclamation paint. Let us see what is happening. Paint is not there, so whatever is under the operating system, that will come out. Okay, so this is what is exclamation, that means cell escape, but that is not a very important punctuation. The important punctuations are transpose, assignment. Then another important is at the rate. So at is actually used for function handling, right? So how to use this at? Let us see. I shall tell you how to use this at. What is this at? Suppose before that I shall tell you about some function called fmin_unc. This is called on constraint optimization. This function is called on constraint optimization, fmin_unc. It is in the optimization toolbox. So a function called fmin_unc. So I will be using this on constraint optimization, and then I will use the function handle. You can see fmin_unc. So what is fmin_unc? Let us see the help of fmin_unc. Help fmin_unc. What is it? So you can see this is used to optimize a particular function fun, which will start at x0. X0 is the initial value and it will give you the final value. So it uses different kind of optimization methods which we shall be discussing eventually, but at the moment we should not be worried about it. So here actually I shall make a function. Let me write a function. Let us say I want to write a function such that the function has to be optimized. My function is like this: x square plus sine x plus, let me write down like this, x square sine x plus e to the power x. So I want to optimize this function. Let us, this is my function, x is the input. I want to optimize this function. That means I want to find out the minimum value. So let me first plot the function. So my x is, let me take x to be lean space. That means I will create linearly spaced vector. Remember, minus 10 to plus 10. I will create, let us say, exactly 1000 points, or let me produce 2000 points. So that means x is a vector having range from minus 10 to plus 10, and the number of points is 2000. So what is y? Y is equal to x, then I will write x square. So I cannot write x square, because x square, if you make, because x is a vector, this will give you error, because vector cannot be multiplied with itself. So it has to be element by element square. See how I am writing. This is very important. So I have created a vector, linearly spaced vector from minus 10 to plus 10. You can see the size of x. You see size of x. Size of x is 1, 2000. That means it is a vector, row vector having 2000 elements, one row. So if I write x into x, it will give you error. So therefore I have to write x dot square, right? Because it is square of each of the elements. Then what? Then sine into x. Then plus e to the power, that is exponential, okay, dot x, right? E to the power x. Let us see. So you got it. Exponential dot, it is not required. So this x square sine x e to the power x. Now you plot x versus y. See what is happening. So you can see this. So the minimum is somewhere here. It is not visible, but here it is the minimum. So if you see, this is the minimum. If you take the graph plot between minus 2 to plus 2, perhaps you will understand, but you don't know where is it exactly. So let us find out where is the minimum, right? So for finding out the minimum from the figure, what I shall do is I shall set the axis range, so that I will not plot beyond that. So x axis I will plot from minus 2 to plus 2, and y axis as 0 to, let us say, 1. Let us see what is happening. So if I plot like this, let us see. Exactly, I got it. So that means where is the minimum value? If you make it grid on, the minimum value lies somewhere here. If I zoom it, I can get it. It is somewhere. Once again, I will operate here. It is somewhere here, is it not? So that is this point. That is between minus 8 to minus, so minus 0.7 to minus 0.6. So that is roughly, you can say, it is around minus 0.665 or 0.655, right? It is minus 0.655 approximately, let us say. So this is from the graph we got, it is minus 0.65. This is by merely visual inspection. Now let us use this f min unc to find the function optimization. This is single variable function, so we will find the optimization. Now let me take the initial value of the function x naught. So x naught I shall take to be, let us say, you take 0.1, no problem. So then I will write this function. First of all, I have to write this function. So file new, how I write a function, please look at me. So now I am writing a function. So the difference between a function and the M file is that function has to be always invoked. Function cannot be an independent program by itself. So therefore function has to be invoked with certain parameters which has to be also passed into it. So that is the basics of a function. That means it needs some external parameters which has to be passed on it. But a program is complete by itself, and program can invoke functions. A function can also invoke other functions. So whatever functions I have just seen, shown you, sin x, exponential, etc., they are inbuilt functions. But I am now going to create another function of mine which will use these inbuilt functions. So how should I write? So the syntax is like this. First you write, the first line should be function, then anything y, x, whatever it is, y is equal to, you give a name of the functions, fn1, fn2, or you can give any other function, try1, try2. Let me give try1. This is my function, try1 x, right? So y is equal to try1 x. Remember, for these functions, when you save, so what happens, the name of the function, what is the name of the function? Try1, right? And the name of the m file, .m file, this will also have .m extension, should be same. That means the function name should be try1.m. So that means that try1 is a function which is saved as try1.m. Now what is y? Y is equal to x dot square plus sine of x plus exponential x, right? Then I can write return or no return, that is doesn't matter. I can write return. If you don't write return also, it will automatically return at the end of the statement. But if you want to use some conditional statements and return, then you have to write this. If you want to break away in between and with some conditional statements, then you have to return from, you have to write return there. Okay, I shall discuss later on. So this function is now, the moment I save it, actually this function is saved. So if you can write here, this is just like any function you can use, try1 0.2, you will get a value. So this is my y. That means try1 is my function now. So I would like to optimize this particular function starting with x naught. So my optimization x is equal to f min unc. Now I shall use a handle. That means f min unc is what? It is another function. So this function needs the handle of try1. What is handle? Handle means whatever is there as parameters, etc., that is called handle. That is passed on to a handle. And this handle is, I will discuss more about handles while you talking about graphics. So right now you can use this articulate and try1. Then the initial value is x naught. X naught. I think this is x naught. So this is our x naught initial value. F min unc I have used try1. You put return. Let us see what is happening. Yes, you got minus 6.555, minus 6554. What did you get earlier? It is minus 0.655. So you are getting the optimum value, is it not? So here the other routines, they are using this try1. I can also write like this. I can give some f1 is equal to handle of try1. Then I can use this optimization. Instead of try1, I will use this f. This will also work. F1, sorry, it is F1. This will also work. But if you use just try1, it will not work, because try1 will be taken as a text. It may not work. Therefore, the moment it is handled, the function will automatically evaluate it. So for evaluate, because f min unc is another function which it needs to evaluate inside its, therefore it needs the handle of the function. So to know more detail about handles, I shall discuss it. I'll get back to it again and again after some time. So just you remember that this is how we can use handles. So this is a very important punctuation. That means at the rate is a very important punctuation. So now you can see. Okay, so you knew about different punctuations. This is where we are. Decimal points, array operations, field access. You last class you have seen, last lecture, what is dot, how can you access a particular field. Then comma is used to separate the, when you are trying to access the particular element of an array, you use comma, semicolon, percentage, exclamation, transpose, dot transpose. You can also use quote. The same transpose symbol can be used to quote a particular text, right? So for example, I can equate. For example, suppose, let me clear all. Suppose I write x is equal to my name, Aurobindo, let us say. It will not take anything, because Aurobindo is, because first you look whether it is a variable or not. But if I write quote, then it will take. That means x is a character whose length is Aurobindo, right? That is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 characters. So after quoting only, it took the whole thing as a character. Otherwise, it will search for Aurobindo, which is a variable, and you will try to numerically equate it to something. If it is not exist, you will get an error like this. undefined function or variable, right? So then you knew what is an handle, then also you knew what is an assignment. So punctuations are over. So you have to be clear on punctuations. All punctuations I have already covered. Then transpose, you can, instead of writing that, suppose I have a matrix X is equal to 1 2 3 4 5 6, then instead I can do transpose by this, all I can do transpose by this. I can suppose y is equal to x plus j into x. So this is x plus j, this is another. So if I write transpose of y, you will find the elements will not be conjugated. But if I write C transpose, it will be conjugated and transpose. So one was dot transpose, that is transpose, and this was simply C transpose. Okay. So they are same thing, but it is written like this. Then concatenation, horizontal concatenation and vertical concatenation. What is horizontal concatenation? Suppose I have a vector y. This is my vector x, let us say. I want to create a, and this is my vector y. Suppose I want to create a vector z which is x concatenated y. So that means first x matrix will be kept, which is a 3 by 3 matrix. By the side y matrix will be kept. So what will be the size of z? The same 3 columns, sorry, 3 rows, but it will have 6 columns. You can see size of x, then size of y, two by 3, size of z will be 2 by 6, right? But suppose w I will write as x semicolon y. That means first x matrix will be kept, in the next row, that means it will get a return, y matrix will be kept. It will be kept like this. One was like this. Look at my slides. Z was x y, and w was like this, x and y, x over y, which is same as x semicolon y. All right. So you can see this. What is w? You can see the size of w. So one is called horizontal. That means there are two. So 2 by 3, 2 by 3. So it became 4 by 3. So it was called horizontal concatenation. Other one is called vertical concatenation. So this, I think you have already known what is this bracket and this assignment. Curly and square brackets is already known. Now let us go to the operators. So these operators are not very important unless you are using binary numbers. So these are called bitwise AND operators, bitwise complement operators. I will just take one of them. Bitmax is not an operator. It will give you what is the maximum floating point number. This is just a variable. You can write what is bitmax, you see. So that gives you the maximum floating point number. See, it is 9 0 0 0.0017 to 10 to the 15. That is the maximum floating point number. What is the minimum floating point number? It is not there. So this is the maximum floating point number, integer. That means integer represented in the form of floating point. Maximum floating point integer. That means the integer which is represented in the floating point format. So that means you can add and subtract floating point numbers from it. Then this is bitwise XOR, bit set, bit get, bit shift, all these things. So I will take one of these. Instead of, because all of them are similar, slightly different functions. So I will take one. Let us say bit XOR. So what I shall do? I shall take A and B, okay, as two vectors. I can also take two matrices, no problem. So I shall do what? So I shall take as A is equal to 1 0 1 1 0 1 1. B is equal to 0 0 0 1 0 0 1. So bit XOR. So if I write bit XOR A comma B, what are you expecting? C is equal to bit XOR A comma B. Okay, so we have been discussing about bitwise XOR. So before that, we may committed a mistake, so we have to do it again. So first of all, you must know what is deck to bin. There is a there is a function called decimal to binary. You can see what is help dec to bin. So this will convert binary number to decimal and decimal to binary. Anyway, so let me have a which is equal to let us say 15. Okay, let us say a is equal to 15 and b is equal to let us say 13. Okay, so this is my a, this is my b. So I want to see how a and b look like in binary. You can write dec to bin a, you can see the binary number format. So like dec to bin b, you can see this is the binary of b. So I shall write c is equal to bit XOR, let us say. I am not writing bit and I can write bit XOR AB. So now you see what is dec to bin C. So it is 1 0 only. You can see A was 1 1 0 1 all ones and this is 1 1 0 1. Therefore, dec to bin C will become 1 0. You can see that means 0 0 1 0. 1 0 means actually the left hand side is 0 0. So because 1 1 1 1 they are same, so you got 0 0. Then this is 1 0 is dissimilar, so it is 1 and 1 1 again same, so 0. So whenever they are same it is 0, whenever it is not same it is actually dissimilar. So if I can also make bit x bit and, if you do bit and, you see what is happening. So write dec to bin C, you will get 1 1 0 1. So a was, we got a was 1 1 1 1 and b as 1 1 0 1. So if you add this with this bitwise, you will get actually 1 1 0 1. So this is bitwise OR and bitwise AND operation. You can also see these numbers by writing format hex. So if I write a, what is a? You can see this is a, this is my b, and this is c. This will give you 32-bit integer actually. The hexadecimal means 64. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So there are 16 bytes. So 16 into a 4, that is 64 bits of integer which is represented like this, a and b and c. Okay, anyway, so if you see help format, you can understand what it is. You can see this, these are different formats where you can we can display the numbers. Format short, format long, format is actually format hex, format plus, okay, format bank. So these are all different kinds of formats. So I shall again write format which will go back to my default format. Is that clear? So my a was this, b was this, and c was this. So if when I made it binary, you could get it. Anyway, so these are my bitwise AND and bitwise OR operations. Similarly, you can see bit set. You can set a particular bit. You can get a particular bit. You can shift a particular bit. So these are all, you can do whenever you have time. So these are all very simple things. So suppose what is my a? A was this. So if I write, I want to shift, let us say. So you can shift a bit. You can see. Okay, so a will be shifted by n bits, you can see that. Okay, so this is, and this is bit shift. What is bit shift? You can see, you can also write help here, help bit shift. You can see what is bit shift. So you can see what is n. K, a is a particular number, it can be shifted by k bits, but n is given so that actually there will be overflow after n. Suppose n is 16, but you are trying to shift a to 20 places, then there will be overflow. So simply if you don't write n, then n will be equal to default value is 53. So let me shift c, shift a, I will write bit shift. Okay, bit shift a, let us say 3 positions. Okay, right. So you can see dec to bin. So dec to bin a, you can see this is dec to bin c. So shifting is just like, as you can see, shifting is multiplying by k. It is 2 to the power k. Shifting is multiplication by k. So you can shift left or right. This is also, you can see. So this is shifting, multiplying by, multiplying and dividing. You can see that. Okay. So k has to be positive. It cannot be negative. So it has to be only positive. So this is shifted towards right only. All right. So now I shall, so actually it is up to you to find out what are the different functions. So each and individual, if you go and see and experiment yourself, you will know whenever you have a need. So these are for logical, that means on binary operators. They will be operating on binary numbers. For each of them, you cannot have non-negative, you cannot have negative integers. As you can see, they are all non-negative integers. It cannot be negative. The input argument to this and or etc. cannot be negative integers. So then we have got set operators: union, unique, okay, intersection, difference, etc. So what is this union and intersection? Let me do one, rest of them will follow. Intersection, let us say. So if A and B are two vectors, what it will give you? Intersection means if when A and B are two vectors, returns the values common to A and B, the result will be sorted. So let me write down. When A, B are matrices with the same number of columns, returns the rows common to both and A and B. So you can also have intersections on the vectors and or intersection in the matrices. Let me try with vectors. Suppose I will first clear everything. Clear CLC. A is equal to, let us say, 1, 2, 3, 4, 5. Let us say B is equal to 4, 5, 6, 7, 8. So I shall write intersect A comma B. So 4, 5. So let us say suppose C is having 5, 6, 7, intersect A and C. So it will give you only one common. Similarly, union, difference, etc. all of them you will get. What is unique? Unique is for the array A returns the same values as in A but with no repetitions. So suppose A is having 1, 2, 2, 4, 5. If you write unique A, you will get 2 will not be repeated. So you can see if you have a repeated observation at same point, you can get rid of using unique. So anyway, these are the operators which are supposed to be on sets. So let us try whether if it is so, then whether I can have some sets which is not numbers. Possible. Suppose A is equal to a character A, character B, character C. Let us say it is having character A, B, C. So B is having character, let us say C, character A and character D. Let us say CAD. Okay. So if I write intersect, so you got AC. It is sorted in the order AC, is it not? Similarly, union, you will get ABCD. Anyway, so this is what you can find out. You can operate on sets of whether characters, integers, or whatever. So these are all about operators. So what we have learnt in the operators, we have learnt mainly the symbols, subtraction, addition, then multiplication, element wise multiplication, power, left division, right division, then element by element division, Kronecker product. We also learned what is the least square solution, then logical operators like equal, not equal, greater than, greater than equal to, smaller than equal to, then logical and, logical or, then logical not, exclusive or. Then you have learned the characters like punctuations, colon, parenthesis for subscripting, square brackets, curly brackets or braces, function handling, then decimal point, structure, field access, parent directory, how to go into parent directory, continuation, then separator, semicolon, comment, operating system while invoking with putting an explanation, exclamation, assignment, then quote, transpose, complex conjugate transpose, horizontal concatenation, vertical concatenation, subscripted assignment, subscripted index, so on and so forth. Very good. So now you also learnt about bitwise logical operators, bitwise AND, complement, OR, XOR, bitmax, that is the maximum value of this, bit shift, bit get, bit set, union, unique, intersection, differences, XOR is member on particular sets. So operators are over. So that means we have already finished. Let us go to our document, the same document which we saved, or you can do it here also. Help, if you see help, so in the MATLAB, forget about the toolboxes, just come to the MATLAB. So in the MATLAB, you have finished the general and operators. So you have finished already general and operators. Let us go to languages. Now onwards, we will start the language, programming language constructs. Okay. So here actually I shall tell you what are important and what are not important. Just like in operators, as you know, the set operators and bitwise operators are less frequently used. More frequently are other operators. All other operators are very frequently used. But here in the language also similarly, you need not learn everything at the first go. You may, I shall tell them in the order of importance. I will write them here. So let us now go to language. So I shall close this into, then I shall go to doc lang. So here actually you can see, while language means actually the syntax in which you are going to write lots of programs. So that means you are in the lang's subdirectory, that is the MATLAB lang, where you have got all these things. Now if you please look at the computer screen. So in the computer screen you can see there is a control flow. There are syntax for control flow, that means how to manage the logical flow of the program. If then else is very important. If else, else if, and, for, while, break, continue, switch case. So these are most important. Otherwise try, catch, they are not so important. Return is not so important. Error, rethrow, they are not so important. So I am writing in the control flow statements what are important here. So if, else, else if, and, for, while, break, these are important. Switch, continue is not that important. Then case, then return. These are my most important flow. This is program flow, logical flow operations or languages. Then there is followed by, in the language syntax you have got evaluation and execution. In the evaluation and execution, only f eval will be important, that is f eval. Others will not be that. Even f eval is not that important, it will come in the second line. All the other things you not need right now, but when you write very sophisticated programs you might need each of them, but I will have to discuss each one of them. Then you got scripts. So script, in this particular script function and variables, this script actually is just the script file will give you the file which is, that is the, I just wrote a couple of script files, you know, where which is carrying .m extension. This could be a function or this could be just a set of MATLAB function commands. So this is the function which is most important here, and I have already wrote a function. How to write a function? I have tell you that the function, whatever function you are writing, the name of the function and the function file name should be same, right? So these are all functions. Then global is important. Global declares the variable, okay, whether it is local to the function or global to the function, right? Then persistent, this is also important, but all others, m file, list, exist, is global, mlock, m unlocked, mis logged, precedence, is variable name, is, these are not at all important. Similarly, argument handling is not important at the point of time, that is number of argument checked, number of argument in, out check, number of out, nrg means number of argument which are in, number of arguments which are out of a particular function. So these are not important at this point of time. Similarly, you got message display, whether you want to write a program where you can write warning, so you can, for warning you will, the message will be displayed in red. Similarly, last error message, last error, last one display, out of them only display will be important, display. So out of the whole thing only display will be important. And fprintf is similar to your C file handling functions, where you can use to write and read from the file. Similarly, From interactive input, you only need perhaps input, which is important, and there is one more, that is pause. Everything else will come next. So first we will use these and write some programs, then we will discuss other things, so that actually the most common things which you have will be using will be clear to you. Then we shall take up the others. Okay. So let me write a program to explain you the importance of if, then, else, and, for, while, break, switch, okay, return, etc. So let me write a program. What program I am going to write? Let me write a program. Before that, I shall tell you what is the program I am going to write. I will write a program to find the zero of a function. Find the zero of a function. Finding the zero of a function. How we will find? So we will be using same famous Newton's method. So let me see, let me take a very simple function like this. Suppose I have a function, let us say this is x axis and this is y axis. Let me say that my y is a function of x, which is going like this, and it is having 0 crossing here. This is my 0. So how do I find the 0 of a function? You can be solved by iterative method. Suppose I take my first point, let me take red pen. So I shall take by iterative method. So my first guess, let us say, is x naught here. Then what will be by next? So this is x naught. X naught is what? This is x naught from here to here. The distance in the y axis, this is 0. And what is this axis? This is f of x naught. Is it not? Now let me differentiate this. If you differentiate, what differentiation of the curve is? Actually tangent to it. Draw the tangent first. If you draw the tangent, if this angle is theta, what is tan theta? Tan theta is equal to, if you find out dy by dx at x is equal to x naught, is it not? So this is called slope of the curve, which is, you can write f dash x naught, you can write otherwise. So what I shall do is, my next guess will be, I can write my next guess. So my next step I am writing, going to write, that is x1 is equal to x naught minus f of x naught divided by f dash x naught. Will I be wrong? No, because this length is f of x naught, is it not? Or f naught you can write, and this is a tan theta. So this by tan theta is this length. So my next leg guess will be x1 here. So as you go on, after some time, this at a particular point here, fx will vanish. Even if this will have some value, it will vanish. If it vanishes, then it will just stay there. So this method will be stable. But this method may not be stable always. But for the timing, suppose the curve, instead of going like this, the curve would have gone just like this, just touched here and gone like this. So here both function f of x naught and f dash x naught would have been 0. In that case, this method would have failed. But we are not considering such functions. We are considering a function where the function is 0 and but the derivative will not vanish. So at those places we will find the 0 of a function. So let me take a function like that. Let me take a function like this. X, let's say my function is y is equal to x minus sine 5x, right? So x minus sine 5x. So whenever it is 0, I want to, that means I want to find out whenever a value of x for which sine 5x is equal to 0. Find x for which it is 0. So this cannot be solved analytically because this is a transcendental function. This can be only solved by Newton's method. So first of all, I have to write a function. Let me write this name of the function as fn1. Okay. So let me write this function first. Then we shall plot the function. Then plot both x and sine 5x and see where they are equal, or x minus sine 5x will plot wherever they are 0. We'll first find out. Then use Newton's method to solve and see whether they are existing or not. So let us do it, and in the meantime we will be using all these if then else etc. So let me write the function file new m file. So what is my function? Y is equal to, sorry, I have to write function first, then you can write y is equal to my writing fn1 of x. Okay, very good. So you write y is equal to x minus sine 5 into x, then return. You need not write return, but it is better. So how to save it? Save it, it will automatically show you in fn1. So that becomes a function. So now you see, so fn1 of 0.1, 0.5, everything is working great. 0.8, they are all working, therefore function is working. Now I want to plot the function. Now I shall take x is equal to, I shall write from minus pi, I shall take linspace, sim linspace minus pi. As I said, pi is a variable which is already there. I shall take some 500 points, let us see. Is x. So what is y? Y is equal to fn1 of x. Now let me plot x and y. So wherever it is 0, that is my solution, is it not? So let me write grid on. So what are the points? It is 0. This is 1, 0, 2, 0, and 3, 0. So that means the function is 0 actually at 3 different points. So here, so that means one point is here. That is, one point is at 0. Obviously at 0 the function is 0. So what are my points? So points where the function is 0 is, one is 0, x is equal to 0 solution. Another is x is equal to how much? Here you can see here minus, that is here, it is between minus, so it is between minus point, maybe it is minus 0.519, let us say, approximately from visual inspection. Then this one is another 0 here, is it not? Because this is 0, this is grid 0 here, so this will be 0, another 0. So that turns out to be similarly plus 0.51, maybe it is plus 0.519. I think this will be symmetrical, correct? So these are three solutions. So this function will have 3 zeros, let us say. Very good. So now I will evaluate these zeros by iterative method. Whether, how can I find out all the zeros? So what I shall do is, I will find out, I will write a new m file. So as usual, I will write clear all, clc, close all. Then I shall save this particular file, let us say in the LRN learn. This is lecture 5 though, so let us write lecture 5. Okay, or lecture 4. This is lecture 4, yes. So lecture 4.m. Okay. So I shall, to write the Newton's method, what you need to do is you need to find out the derivative. So how should I find out the derivative? I will numerically evaluate the derivative. So derivative of a function, as you already know that a function, a single variable function, the derivative, look at my slides. So f dash x will be limit h tending to 0, f of x plus h minus f of x divided by h. Is it not? This is 1 point. Okay, this is my right hand derivative or left hand derivative. This is my right hand derivative. Similarly, you can have also limit h tends to 0, f of x minus f of x minus h divided by h. So let us say the function is continuous. This is my right hand derivative RHD. This is my left hand derivative, you can see as LHD. So both are same because the function is continuous and differentiable. If the function is continuous and differentiable, the left hand derivative and right hand derivative will be same. If the function is not differentiable, this will not simply exist. So how to evaluate it? So I can take h to be small. How small, that will find out, that will be depending upon the experience. It is very difficult to say how much h, how small h you should say take. So you should take h so that it will not be very small, so that there will be numerical error. you should take h sufficiently small, that should not be also any problem in the approximation. So what I shall take, I will take h to be 0.001. Okay. So now I shall start my iteration. That's why it is the for loop for k is equal to 1 to, let us say, I will go for 20 iterations, let us say. Before that, I shall take the initial value of x. So this is my x naught. X naught is equal to, or x1. I can take x1, the first value, 0.3. Let us see. I will take some 0.3, right? So if I take so what will my next value? First of all, I will evaluate the derivative. So derivative will be fd. Let us say fdk is equal to, right? So fn1 of xk, right? Is that clear? Then minus fn1 of xk minus h divided by h. So this is my differentiation, right? So you can write fn1, let us say 1, then fn1 1 minus 0.001. So you take the difference, divided by, so you will get the derivative fdk, right? So you can also write the function value of the function, whether it is 0 or not. Just to take value of the function, you take some other variable. This is derivative, this is f, let us say. So fk is equal to fn1 xk. Okay. So what is my next value? That is xk plus 1 will be equal to xk minus fn1, that is fk divided by dk. But there is a possibility that dk might vanish, so you will write an if statement. If absolute value of dk is greater than epsilon. Epsilon is a small positive quantity, as you know. Epsilon inbuilt, it is to the power 2 into e to the power 10 to the power minus 16. So if only if this is greater than this, you do it, otherwise you don't do it. So there will be end of this if statement. Otherwise, else what are you going to do? Else actually xk plus 1 will be equal to xk. So this is the end of the if statement. I can just, for the sake of, so this is my, to make it nested a little bit, so I have done like this. So this is my nested, right? So then end of the for statement. Good. So whether this is working or not, eventually you should be able to plot it. So how to plot? Subplot. I shall, subplot means this will divide the window into two halves and choose the first one. So I'll plot x. Then I'll plot in the next half. What shall I plot? Subplot. I'll plot the function. Let me see what is happening to my function. Plot f. Okay. So this is over, right? So let me execute it. So you see how I have put the if statement and else statement, for statement, all everything. You can also put while, break, everything. So this is not a big deal. So you can see here, if I execute, there is some, this is your x, right? Then if function is not becoming 0. The function is not becoming 0, what you are going to do is you take the initial value. Initial value was, instead of that you take 0.123. Let us see. You got 0. That means your initial value after changing, you got the function value to be 0. That means it is working. The function is, one solution is 0, is it not? So now instead of taking 1, 2, 3, you take minus 131. Let us see what is happening. It is again coming back to 0. It's very interesting, is it not? We are not getting the other solution. Now let me take a point What is the, let me take a point minus 0.5. Let us see. It has gone. It has gone to minus 0.519, of course. That means the zeros, the final zeros where it is going to give you the solution depends upon the initial value of this guess. So let me take this initial value from the keyboard x naught. So how shall I do? So I shall use display. See how I'm using display. So I'll write give the initial value. Then I shall take x1 is equal to input now. See what is happening. So it will ask you here in the screen, it will ask you this, what are you going to display the initial value. So x1 will be how much you are going to give. Suppose I write 0.4. This is the final value. You got 0.519. Can you see that? You got 0.519. So therefore, so this is how you obtain the solution, is it not? So from starting from different values, you start from any value. Let us say you start with 3. It will oscillate because it cannot get you the solution, because that particular function, the derivative sometimes will vanish. As you have seen that you write clear all, you will see what is happening. So you did, this one, y is equal to this one, you plotted x and y. You see the derivative of this particular function, once again you plot, this is vanishing at these places. So the derivative, the moment derivative vanishing, you cannot go further because it will end into a trap. It will become very high. It will oscillate because of because of the fact that here you have got a derivative term which is getting divided, right? So you cannot use this to really get into the solution. So next class again we will start about this simple language constructs. We will write different programs and we will see how we can effectively use the syntax to do wonderful things. Thank you very much.